hopefully today will be a nice review where you're like, oh yeah, I remember doing that. So f of x and g of x's are inverses for every point a, b on the graph of f of x. Or if they are inverses, then there is a corresponding point BA on the graph of g of x. So whenever we're talking about inverses, it switches our x and y's, right? If we want to find the inverse of a function, we can switch the x and y's. So if I'm given this table right here, and I'm told that g, f, and g are inverses, and I want to make a table for g of x, what do I need to do? Just switch them, right? So like that top line would be 5, -2, -4, 0, 1. The bottom line would be 2, 4, 6, 9, 10. Okay, so just your x and y coordinates are going to switch for that. That's all we're doing like that. Obviously, like they're not going to ask us to do this on the AP exam. This is like a review building up to what we're getting to is we got to be able to do derivatives of inverses. But we're not getting there today. We're just reviewing because we need all these pieces. So if f of x and g of x are inverses, then the graph of f can be reflected over the line y equals x to produce the graph of g of x. And I believe this was like a square root kind of function. So if I have this red graph right here, and this is my original function, I can reflect it over this line to get this graph right here. Notice your points right here. I've got the point 2, -3 here. That means what other point should be on my graph, or on the graph of my inverse? -3, 2, and here it is. Right? Right here, this point right here is at 3, -2. That means on the inverse graph, I should have -2, 3, and -2, 3 is right there. You could see, here's another point. That is at the point 6, -1, and over here I've got -1, 6. So those x and y coordinates are just switched there. So sometimes, like if you're graphing inverses, it might be a little hard to tell if it is flipped over that line, because I'm not great at like visualizing that. I can like flip it over the x-axis or y-axis and tell a lot better, but this will help you check if you need to know there. All right, continuing on. Corresponding points on inverses. So now this I can't remember if we did or not. We might have. I can't remember. If 3, 4 is on the graph of f, name a point that is on the graph of f inverse. Now this we did for sure. What we got? We got 4, 3. I want us to think about this with a little bit different notation. 3, 4 is on the graph of f. That means f of 3 equals 4, right? That's what this means. So name a point on the graph of f inverse. We would say f inverse of 4 equals 3. A way to sort of think about this is like your original point was 3 to 4. So if I plugged in 3 into the f function, it took me to 4, right? So if I plug in 3 into f, it takes me to 4. So we get in like some of my proof classes, we would say it maps it onto 4. The function that gets you back, that takes you back to where you were, that is your inverse there. Okay? So, if I have this graph right here, it asks me, this is the graph of f. it asked me to list 4 points that are on the graph of f inverse of x, right? So if I just look at the points that I've got, I'd probably pick something easy on grid lines, maybe like this is -6, 4. This point right here is -2, 0. Right here you got 0, 4. Pick one out here. This is 4, 3. Those are all on f of x, right? So the points on the inverse would be 4, -6, 0, -2, 4, 0, and 3, 4. There. Okay, you guys remember most of this? Okay. All right, so here is, I can't remember if we did this in pre-cal or not, but this we definitely need a lot for what we've got to do with the inverses. We know that f of 3 equals 5, f of -1 equals 3, and f of 5 equals -1. We are supposed to find f inverse of 3. Anybody know what it is? It's -1, right? Because what we're thinking of here, like in the original problem, -1, if we plugged it in, it gave us 3, right? That was what happened if we used the f function. F inverse goes backwards, so that means whatever the x is here used to be the y over here, right? So this was our y. This would take you right back. F inverse of 3 equals -1. So whenever you're doing an inverse, whatever is the x here was the y in the original equation. They just put these other ones over here to distract you, to confuse you on what you were looking for. Okay, so let's do it with a table. This is the table for f, not f inverse. We want to find f inverse of 4. What is f inverse of 4? It is 0, because this is the x coordinate here for the inverse, which means it was the y coordinate over here for the f of x. So we give the value that goes with it, and we will get 0. It's a fairly simple idea. Somehow it confuses me whenever it's like in the scope of a bigger problem. There. Okay. This is review. This is finding inverses. I know for sure we did quite a bit of this in pre-cal. To find inverses, you switch the x and y, solve for the new y, replace with f inverse if it is a function. So this f of x is really just treated like the y. We are going to switch them. We'll get x equals y minus 3 cubed minus 5. So, let's see. Lucas, what would I do to solve for that y there? Yep. We're going to move that 5 first, so we'll add that 5. X plus 5 is going to equal y minus 3 cubed. What comes next? Cube root. Cube root both sides. So we got the cube root of x plus 5 equals y minus 3. And last thing, add that 3. I like to write it up front, 3 plus the cube root of x plus 5, like that. You could put it on the end, just be careful, don't put it underneath the square, underneath the cube root. It's not inside of the cube root. And then we'll usually write this f inverse of x equals 3 plus plus the cube root of x plus 5. Okay, everybody good here? That I know we definitely did in pre-cal. Really, you even do this in Math 3. There. Alright, let's see if you guys can do this one though. Let's see if you remember how to do this one. I want you guys to try that one on your own. I'm going to freeze my screen so you cannot see my work. Your y will be bisect. So if you're like, if your inverse has a y equals and then has a y over here on the side too, then it's not going to be. Yeah. You'll have two y's originally, like in the, yeah, you'll have two y's, and so you have to figure out like how to get those y's together. Anybody got it? Let's see. Got it. Where you got that negative orange is not like that's your new x. And then these are your y's. We'll switch your x to your y's. I will say these problems are very similar to implicit differentiation as far as how you solve them. Very similar, although there is no implicit differentiation in it. Let's see.
Oh, okay. So this is a y, so I plug this whole thing in for y.
I was thinking that, but I realized you still have to find. Which, yeah, I'm plugging in for y.
That's the first part.
It's the only one on that side. Yeah, but if you plug it in, you have to plug in this entire thing, which has a y in it. So you just plug this entire thing in, back it up.
Okay. All right. Let's look at it. To me, I think you'll be much better at these types of problems. Like now that we've done implicit differentiation than you probably were when we did them in pre-cal. We did a few of these in pre-cal, but not a lot of these in pre-cal. So you're going to switch them. Then you need to multiply both sides by y minus 4 so that you don't have anything in the denominator anymore. So I might should have written this step x times y minus 4 equals 2y plus 5. And I heard a lot of you say, oh, because it makes sense. So, then you'll distribute. And then you basically treat it like we've been doing the dy dx problems, except for it's not dy dx that you're trying to get by itself. It's the y's that you want to get by itself. So I moved all my y's to one side. I've got xy. I moved the 2y over here to this side, so it became negative. I moved the negative 4x over here, so it became positive. And so if you have all your y's on one side, you can factor it out. Divide by x minus 2, and you've got it solved for y. Mm-hmm. Yes, because, so Lexi, and that's a good question. Lexi has this. She's got negative 4x minus 5 over 2 minus x. That's equivalent because if I took the numerator of this and multiplied it by negative 1 and took the denominator and multiplied it by negative 1, that's what I would get here. So that's equivalent. I think you just moved everything to the right side, whereas I moved everything to the left side. That's the difference in how we wrote our answers, I think. But they would both be correct. Although it is important to know that because if some inverses is not, they're not going to ask you just an inverse problem. But if something like that was multiple choice, they might leave it either way. So you'd have to be able to get them to match. Okay, questions there? All right, let me see. What have I got left? How many have I got? Okay. Okay. Proving something that is an inverse. The proof of something that is an inverse is not just like finding the inverse of it. So the definition of an inverse is that function g is the inverse of f if f of g of x equals x for all x in the domain of g, and g of f of x equals x for all x in the domain of f. So if I do f of g of x or g of f of x, I should just get x. That's because g and f undo each other, right? So I plug it into f, something happens to it. I plug it into g, it undoes whatever just happened to it, and I just get the x back that I started with, right? So if you are asked to prove that two things are inverses, it is not wanting you to switch the x and y's and solve. It wants you to find f of g of x. So like if I do f of g of x here, that means I would be taking g of x and plugging it in right there for the x. So I would have 2 times the cube root of x plus 1 over 2 cubed minus 1. And what should happen is like things should start canceling, boom, 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 until you're down to an x. But if you were having to like show your work on this, you can't just like mark everything out and put equals x. You got to show like how that happens. What would cancel first here? The cube root and the 3, or the cube. So that would give us 2 keep this still in parentheses, x plus 1 over 2, but you don't need the cube on the outside anymore. Like that. Okay, what would cancel next? The 2's would cancel next. Then we got x plus 1 minus 1, and that gives us x. So that works. I have not came across any question ever that works one way and does not work the other way. But I'm guessing there might be one somewhere. The definition tells us that we have to switch these and try it the other way. So you would also need to do, let me use a different color. We'd also need to do g of f of x, which means we're taking f and plugging it in for the x right here. So that would look like this. I'd have the cube root of 2x cubed minus 1 plus 1 over 2. Okay, what cancels first here? The 1's cancel first. That gives me the cube root of 2x cubed over 2. What cancels now? The 2's go first. 2's go first. And then you got the cube root of x cubed, and that just gives you x there. So that would prove that those are inverses. We don't have time for the last one, so we'll skip that one.